Tonight's program is power line noise, what to do before calling the power company. And I'm sure most of you know Ed Edwards, a longtime member of our club, K0IL. And Ed is a senior telecom engineer for OPPD. And one of his many duties is overseeing the department that tracks down power line noise. So let's welcome Ed.
Well, I don't exactly oversee the department, but the crew, the techs that are in that department are part of my group. And since we are RF guys, we get the RF type of problems handed to us. Let's get this thing going. Let me get it running. There we go. Can everybody hear that?
Yeah. Sounds like power line.
Yeah. That's power line noise. And that particular one there, I'll explain later, but it's one that was in my neighborhood and bothering me on 10 all the way through 160. So that was something we'll talk about when we get to it. Now, why should you guys, as hams, have to do anything, right? That's kind of the feeling that some people might have. And so I'll give you some excuses or reasons. One of them is, first thing that maybe we need you guys to do is to first eliminate non-power line noises and make sure it's not something in your neighbor's house or your house or whatever, you know. There's a lot of sources, and I've got a list of them coming up here, of all the possible electronics in your house that can cause noise that sounds very similar to power line noise. And so, you know, it's even hard for us to tell at times. We can show up and it sounds like power line noise to us, and then we'll go out and track it down and think, oh, it's in your neighbor's house, sorry. So, you know, a lot of times we do hunt stuff down and it's not always power line noise. So that's, and the fewer times that we get calls that say, you know, hey, we got power line noise, and it turns out to be something else, that means you know, we sent a tech out and you spent time on it, that's going to drive up electric rates. The more we have to do that kind of thing. So to reduce rates, we kind of like to, you know, have you guys at least take the first couple of steps, and I'll go through those here in a little bit, what those are, before you give us a call. And then, like I said, another reason, if you've already eliminated some of the things for us, we don't have to spend time on that, and we can actually get right to the power line noise then and get it fixed in a lot faster time frame, get it resolved a lot faster. And sometimes it takes a lot longer. Tracking power line noise is kind of an art. It just doesn't lend itself readily to saying, yeah, there it is, because when you walk out with this equipment, and I'll show you some of that, there's dozens of noises out there, and there's only one probably bothering you. So we got to get it tracked down to figure out which one is the actual noise that we need to fix. And the other reason for you guys to learn about radio interference of any kind is it basically enhances the technical pull of you guys, the ham radio operators, and that's kind of the essence of what ham radio is about. And that's what we have actually learned something if we look into it. So, all right, interference. What is harmful interference? And the FCC defines that in Part 15. It says any emission, radiation, or induction that endangers the function of a radio navigation service or other safety services, and then underline this because this applies to us, or seriously degrades, obstructs, or repeatedly interrupts a radio communications service, that includes us, operating in accordance with this chapter. So it does address us in that part of Part 15, and that is the reason why you hams can call up and say, I've got power line noise, it's interfering with my radio, and we have to go fix it, because it's in the FCC license, or rules and regulations that you have to do that. So, what should hams do? Well, educate yourself on various line noises. Another step is do some analysis, and we'll get to how to do that. Another one is eliminate in-house noise sources. Make sure it's not coming from your power lines inside your house. And then you can move on out from there, check the outside sources around your house, and also you can walk your neighborhood with a little radio. I've got a portable receiver, multi-band receiver that I can carry around. Those are kind of nice because you can put it close to your body, and then as you turn around, it kind of, well, you guys can do transmitter, and I can probably do the same thing with your 2-meter rig, so you already know that. I think I've done that a few times myself. Oops. And The transmitter hunt, you can practice RF signal tracking, and that is the same kind of thing. You're tracking down a source that is unknown, you're trying to find where it's located, so you're doing direction finding and all that stuff.
Can you go over what type of radios would be good to utilize?
Yeah, I've got a picture of, well, I've got one shown here, and the one I hear the most about is the Kenwood what's the model? I can't say. Yeah, F6, that's the one. And
Portable?
yeah, a lot of guys that are on the RFI reflector on contesting.com have all said that that's one of the better ones to use. If you look up anything on contesting.com under RFI, you'll find a lot of things related to power line noise and other kinds of noises. It's a really good group that, you know, a lot of guys on there that know a lot about interference and all the, not just power line, but all kinds of interference, because there's a lot of things that can cause it. I was talking about where you can learn stuff about radio or radio interference from power lines. This book here is an older one that's out of print, but if you can find one somewhere to grab it, it's definitely an excellent reference book for interference. It was written by a ham who was working for, I think, what is it, Southern Cal Edison. And this was back in the 60s when he published this, and it still is good today, because really power lines haven't changed a whole lot out there, so this is a good book on it. The ARRI has an RFI handbook, and there's a whole chapter devoted to power line noise in that. And that was written by also a ham who's a utility RFI tracker. And this one here is probably one of the better ones. We keep this in multiple places in our shop for the techs. It's the AC Interference Manual, written by Marv Lofness. He is the one that has written the book on how to track noise using signal signatures, so that you can find what the noise is on this pole and does it match what the ham's hearing on his antenna. And you can do that with a scope and a receiver, and then you can actually see, here I got 4 spikes on this particular noise that the ham's hearing, so you go out and look at all the different noises in the neighborhood. All the other ones have maybe 1 or 2 or more. And you get the one that's a match, you fix that pole, the ham's problem is solved. So that actually speeds things up. We don't have to randomly go fix this pole and that pole and hope to find it. So he wrote the book on that whole method of fast tracking down information. There's been several QST articles over the years. There was a couple of good ones back in 2005, 2006 that I've noted there that talk about power line noise. Kind of covers a lot more than I'll be able to cover in this short time frame. But if you want to find out more information, I would research that on ARRL.org website. They're out there somewhere. All right, noise analysis. I talked about analyzing noises. And one thing that's important when you're experiencing noise to your ham station is to keep a log of the noise, because the noise will come and go. We were just talking to somebody who said, yeah, I've got noise that's starting up, but it comes and goes. So it's, you know, hard to figure out when it's going to be on and coordinate that with the utility worker that shows up. And he's only going to come during between the hours of 7 and 3:30. So really, if the noise is coming and going, you might end up meeting with him 4, 5, 6 times before they finally link up with the noise being on at the time he shows up. I got some recordings here, and see if you can hear these. None of them, I think, is that same one. There's one where it started with just a couple of clicks, and it gets loud for a while, and then it goes back to clicks. So it can be blocking out very little portions in time of what you need to hear, but overall, if it's coming and going like that, you're just not going to be able to use your radio too well. You'll be asking guys to repeat a lot. It's just annoying as heck. So some of the other ones, let's see. And what'll make the difference is basically receiver bandwidth. So as you change from AM to single sideband, it'll sound differently to it. And so you record it, it'll sound differently than you record it. That's pretty consistent. That's going to be easy to find because it's kind of on all the time. And it's just there all the time. So And then that other one that we started off with sounds sort of like a Jacob's ladder, doesn't it?
Are those all coming from power lines?
Power line equipment of some sort. That last one there is what I had in my neighborhood, and what it turned out to be was a squirrel guard that had gotten bent. And then when it would rain, the rain would cause that arcing. And then eventually when it got wet enough, it quit. Or it would get all, even worse and go full blast on all the time. And it would just depend on how cold or how moist the air was as well. So there's a lot of variables here that you may not even think about until you're sitting down and saying, okay, this was on at this time and it was raining. If you write it down, then you kind of got an idea of what happened. And if you make a log like this, you can start to see patterns in what you write down as to why it might be happening. And also write down what freaks are affected. If you got a multi-band antenna tuned across all your bands, be aware that if you have a shortwave receiver and you've got say a 5B TV or 6B TV antenna, as you tune in between the bands, it's going to sound like the power line noise is getting weaker. It's probably not. It's probably getting stronger if you're tuning upwards. And it's just your antenna's not tuned to that frequency. So kind of keep that in mind too, that it's going to change with whatever your antenna tuning is as well. So if you've got maybe an automatic antenna tuner, check at the top and the end of the band and use a tuner to shift it. You want to figure out, is it broadbanded or is it just little 25 kilohertz wide splotches of noise here and there? I've had touch lamps that were about 40 to 50 kilohertz wide, and I think they were every 100 or 120 kilohertz, you get another band of them. And they would shift depending on how the light was operating. If it was off, it would be down here. If they had a three-way bulb and it went up, it would shift up. And then they hit it again and go up, up, and then down. So, you know, if it's really broad-banded, it's probably power line noise. If it's very narrow-banded, it may be something else around the house or in a neighbor's house. So you can kind of gauge based on the bandwidth. Also, does it affect TV? And that's not even a big issue anymore. Hams are the main victim, I'd say, of power line noise today, because most people have cable TV. It doesn't leak in or out for the most part if they are following their FCC rules. So you've got very little or very low numbers of interference. But that started up again back when they started adding telephone to the coax cable system. What was that, about 2000-something, 5, 6, or maybe earlier. And we started getting a lot more calls from coax cable, not from the customers, but from techs that would show up. They find they've got interference in that area. And they might have a leaky cable too, but they didn't want to have to fix it right now, so they call us to come fix the power line. So we've been doing that for the most part. If it's something that even when we clean things up and they're still having trouble, we're saying, look, fix your system first and then call us again if you have a problem. And most of the time they don't call back. But plus you got cable, you got fiber to the home now, and that's what I just recently had put in my house. That opens a whole new can of worms. I found out, because I've got the CenturyLink's Prism TV, and I had one box that's directly hooked up, hardwired, and then that's hooked up to the TV. The other two boxes were wireless to the TV, and that wireless box on the TV was putting out enormous amounts of interference from AM all the way up to about 40 megahertz, 40 meters band, 7 megahertz. And it was just very broad-banded, very noisy. And at first I thought it was power line noise, it sounded like it. And so I was kind of waiting to fix a problem in the neighborhood. And finally I figured out, well, it's interfering with my garage door opener too. Well, wait a minute, where's that at? It was right on top of the garage door opener, right below where that box was in my son's room. And then I figured out if you got about 20 to 30 foot away, that interference completely went away. So it's very short range, but it was very strong when you were in that 30 foot range. So again, there's things in your home that may sound like power line noise, but turn out to be something else. even fooled me for about, I don't know, several months before I finally got around to figuring it out. And I had them come pull all those out and hardwire everything. Now it's all clean again. So keep that in mind if you're switching over to Prism TV or I don't think Contour has that problem because I think it's all on cable still for coax cable. And if you got telephone interference too, that could be from power lines, and that could also be from just a bad ground in the telephone system as well. If they didn't ground it properly where it enters the house, that could be an issue as well. Also in your log, you want to keep track of when it's active. Is it just in the mornings? Is it just in the evenings? Write down the time. Also, figure out if it's only active when a neighbor comes home. It may be something he's turning on or turning off when he leaves. So if it goes away when he leaves, you can kind of figure out which neighbor it is that's maybe causing the interference too. And then also, like I noted before, you want to jot down if it's rainy or dry at the time. If it's been dry for a long time and it starts up, it's probably something on the power lines then if that happens. All right, another thing to do is check your ham shack. Make sure all your connections are secure, both inside and outside the house. I recommend, if you haven't heard of this before, use a single point ground system for your ham shack. That will help protect you from any lightning problems you might have come your way. It'll also reduce your problems with the receivers picking up noises that they would normally wouldn't hear. As long as you've got a good ground system, good bonding throughout your cables and your ham shack, your antennas, then you kind of ward off some of the other problems that just start to appear when you don't have everything hooked up quite right. I also recommend not using braided ground wire. I know they sell it in a lot of the handbooks. If you use braided wire, use it only indoors at least, and try to keep it insulated. I'm also guilty. I have some braided wire in my ham shack, but it's indoors, so it hasn't really caused me any problems. What that can do is that can create a bunch of PN junctions throughout the braid, and that can be sources of noise all on their own, or they can amplify other noises. So that's one thing to watch out for. Check your outdoor antennas, or actually check anything that's metal outside the house. You can have corrosion built up, and they call it the rusty bowl effect. And if that's anywhere near a power line or wiring in your house, that can actually induce more noise coming in your house that way. Now, I also mentioned check your house, and basically here's the way to check if it's inside your house. You want to put your HF receiver or whatever radio is receiving the noise on battery power. Then you go in and trip your main breakers on your house. So always get clearance from the wife first, because if you don't tell her, she's going to be mad. But yeah, trip the main breakers. That'll shut the power off to your whole house. Now listen for the noise. If it's still there, it's not in your house. It's coming from outside the house. If it disappeared, it's now inside your house. You know where it's. You figured out which building it's in. Now it's time to track it down. So you reclose your main breakers. Now you can start tripping your breakers one at a time, figuring out which circuit is the one that has the equipment that's making the noise. So once you find that breaker, that circuit in your house, then you got to go figure out, well, it's plugged into that circuit, and you start unplugging things from the walls, and you see what finally is the unit that makes it go away. Yeah, it's usually wall warts and stuff like that. Anything, well, if it's one of the old-fashioned wall warts, probably not a big deal. Those are nice and clean for the most part. If it's one of these newfangled light-duty ones, but that's a switching power supply, that's going to be trouble. That is one of the biggest complaints on the RFI reflector from a lot of people. All right, so let's go through a quick list of in the house sources that you can look for. I of course have at the very top, touch control lamps are pretty notorious, especially if they're made in China. That's what I found at least. Switching power supplies, we just mentioned that. That's definitely something you find on a lot of equipment today. Computers, some of them are worse than others. Some are clean, some are not so clean. Laptops, I've heard can be kind of noisy if they've got a real bad power supply in them. The old-fashioned light dimmers and speed controls have always been a problem. If they start going bad, they start giving you noise. TV monitors, TVs, monitors. Now, booster amps, I think, John's still here, I think he tracked down a TV booster amp that was in a RV someplace. And they just came in from out of town, and all of a sudden they had noise on 9-4, and we started tracking it down and figured out it was a booster amp in this RV that pulled into town that night. So, a lot of these booster amps are just really broadbanded, they just pass everything through them, so if they park next to a real strong source, they can actually amplify it out to everything in the neighborhood. Plasma TVs are terrible noise sources. Yeah.
What is a booster amp as far as?
It would be something that you'd mount up close to the antenna. A lot of people put these in their attics.
Okay.
Back when you had antennas
All right.
before cable, and now they're putting them on RVs for people so they can put up an antenna when they get into town and pick stuff up.
Yeah, I know what you mean now. Antenna. amp.
That's what it is. Yeah.
Okay.
That's a little signal booster basically.
There was a known problem with the mine guards, during a
I
certain
remember hearing
time.
that too. Yeah.
And we actually tracked one down in Glenwood.
Okay.
And the lady took the RV to the RV dealer.
Was that the one John was involved in?
He was there too.
Okay.
There's the whole group that went looking for it, because it was wiping out 2-9 down in Glenwood.
Oh wow.
And I believe the county sheriff was on high band.
Oh.
So it was taking out their routine
Ouch.
too.
Wow.
And she took it to the RV dealer, and they said there's absolutely nothing wrong with it.
Of course, he's going to say
And
that. Yeah.
She happened to have this piece of paper that had the FCC on the top.
Says this shall not cause harmful interference, and it shall receive any and all harmful
Uh-huh.
influence.
And they put a new one in for her, no charge.
Yep. Yep. Once they see the regulation that says you got to shut down when it's causing interference, they're done.
Plasma TVs also.
Yeah, plasma TVs have been a really bad problem, but now they're not making them anymore. I think each vendor's finally dropped making plasma TVs, but there's still a lot of them out there. I know there's a ham in somewhere in Illinois or Indiana who complains all the time on the RFI reflector. He doesn't want to go bother his neighbor, but his neighbor has a plasma TV. He's wiping him out on 80, 40, and 20. That's it. You can't even get on those bands. I say, go talk to him. They might be willing to coordinate with you on some things, you know. But he's just waiting for it to die. And then he'll be happy, I guess.
TV or the neighbor?
Yeah. Doorbell transformers, we found those to be rather troublesome over time. Fluorescent lights, if they're, neon signs can also do it.
I had a fluorescent light in the basement that had that problem. Come to find out, it had been recalled. The transformer had been recalled because it was so noisy.
Yeah.
And so, I replaced it with something better.
Yeah, and another problem is if you go to the big box stores and you buy stuff like this, sometimes it's not made for being in homes. It's industrial, not residential.
Yeah.
And you got to look on the box for some indication of that. Be sure not to buy industrial, because that's going to be a problem in your ham shack. And if your neighbor buys that, go talk him into going and sending it back and getting one made for a residential house. That would be a much safer one to have in the house anyway. That's the way I would put it. Electric blankets, another thing. I mean, the list goes on and on, actually. I just covered the big ones that we've found over the years.
Fish
Yeah.
tank. You got a
Fish
fish
tanks,
tank?
yes, I do.
Put your heater in, they go on and off?
Yeah, I have.
Boy, are they hard to find. Yeah, they always been trouble.
Grow lights.
And your marijuana grow lights.
Actually, I need to add that to the list. That has been the biggest problem in certain states in this country. And RFI Reflector's full of information on that if you want to look it up. A lot of hams complaining about that. And then the hams are afraid to take any action on that. I mean, who are you dealing with? He's growing pot. He may have guns too. You don't want to go up and complain to him.
I mean, man.
So,
Or he
it
may
is a
just
big
give you
problem.
something to settle you down.
Yeah. You don't need to complain anymore. Yeah? All right, so then you get outside your ham shack, what are you going to do? Are you going to use a Yagi? I brought one along to use. Actually, this is a log periodic, and it covers a pretty broad spectrum of frequencies. And so you could use, and I think I've got a picture of one coming up here. But
It's like you tell people you're.
we got this at Radar Engineers. They make them for utilities. And this one comes with the receiver unit that we bought. And so, but, you know, just about any kind of handheld antenna, UHF antenna, or even a pretty large VHF, you could probably use that as well. You can get some direction finding. Anything you could use for a transmitter run, of course, will work too.
Sure.
So you could check around your house with a portable HF receiver, or even a little handheld F6, or I've got a VX5 that I use, and it works pretty good.
About a broadcast AM radio, which is small.
Yeah, the thing to keep in mind is whatever you're listening to for noise, you want to be on AM mode, not FM.
Yeah, of course.
You're not going to hear the noise on FM as distinctly as you will on AM. In most cases, you won't hear it at all on FM.
Well, even just an AM transistor radio, some of the older radios have pretty good receivers.
You also want to be on the high end of the band,
Right.
on 16,
Yeah, and
1600.
what you want to do is you get closer and closer to the source as it gets stronger and stronger. You want to keep going up in frequency as well. And as you do that, you're getting closer. That way, if you get too far away from it, you'll see it went away. Oops, I got to go back to here now. So that's one thing to keep in mind is, and I'll show you a chart here that shows how that's related. So as you're walking around, you want to note any place you got noises. I got noise by that pole, I got noise by that house, or whatever. You just want to write all that stuff down. As you get, like what I just said there, as you get closer to the noises, if it's getting stronger on, say, 40 meters, or if you're carrying around a short wave, it's on 10 meters, it's getting stronger. Now switch to VHF and start listening up at the higher frequency. Inspect all of your antennas in your ham shack for any corrosion. I think we mentioned that once before. That can be you're just feeding it into your system, making it even worse. Inspect the nearby metal objects. If you've got a metal shack in the back of the house, storage shed of some sort, make sure that all the places where the metal meets, that it's firm, it's not loose. If you got pieces that are sliding like that, you've got a possible corrosion effect there that could cause a V-in junction, and that could amplify some signals near your antennas then, so that they bring it in. And clean up any corroded items, like I said, not just antennas, but on anything that's metal. Okay, so as you finally get around your house, you already figured out, well, it's not really by my house, so now I'm going to start walking around the neighborhood. Good place to start with an HF rig or low, low VHF band. Note the noise level. And as I mentioned, if it's getting stronger on the frequency you're on, now change your frequency, go up higher. Go listen to the higher frequency. And then when you get into the UHF band, you're probably within a block of the doggone source of noise at that point. So you can probably start looking around, seeing how many poles are there right here. If you're a UHF, you're really close. I already mentioned that. Another thing I found is that if it's being conducted down the line, and I'll discuss the 4 ways you can get it propagated to you. If it's being conducted down the line, and you're just walking along the line, you're going to notice with the antenna in one particular orientation, as you're walking along, it'll get stronger, and then it'll get weaker. And it'll get stronger, and then it'll get weaker as you keep walking down the block. And wherever it gets really strong, if you go like that, you'll notice it's a weak point here in the vertical. Strong and weak. And it'll just be that way all the way down. Because this is an electromagnetic wave, just like a radio wave. And that's what you're hearing off of the old spark gas used to be, basically just nothing but a spark. And that's what you're tracking. It's an old spark gap transmitter. This shows one of them small portable HF receivers that you could use. Has anybody heard of Texun? T-E-C-S-U-N? A lot of people say those are excellent for tracking noise on HF. I'm going to try to get my boss to talk into letting us buy one for our tax. The Florida ham that tracks down in Florida for the utilities down there, he's got a Texun 600, I think it is, model 600. And he just loves it. He says that sometimes that's all he has to use to go out and find noise. And between that and a loop antenna, he's good to go, he said, for HF interference. And basically, this is what a loop would be made of. If you want to homebrew one of your own, you've got a couple of variable capacitor, another capacitor, and a loop tuned for whatever frequency you want to tune it for. it's not real complex, but if you have an antenna that's smaller than the band you're listening on, you're going to find the maximum signals off of the sides of the lobes. So if it's sitting here this way in a square or circle, whatever, it's going to be maximum signals will be coming off the sides. Whereas if you've got it tuned for the frequency that you're on, if you've got it tuned, say, for 10 or 20 or 40 meters or whatever, now the peak will be this way. But it's easier to see the nulls as you turn this thing. You'll be looking for the noise more with the null than you will with the direction. You'll say, okay, here's the null, so I'm this way then. That's kind of the trick that I found on those. Here's one with a UHF, and is that a yeah, it's a Yaesu. Yeah, I think it is. Looks like mine at least. And a nice, I'd say that's a UHF antenna that they can carry around looking for noise. And this one covers AM on both VHF and UHF, so you can kind of walk around changing bands as you go along. So I talked about conduction down a power line. So there are actually 4 ways that noise propagates through power lines. You've got the noise source direct to your antenna receiver, and that's shown on the right-hand side there. And if you're close enough, you'll be getting the interference directly then. Now, if you're not close enough to hear that noise source directly, it can still conduct down the line. And as it conducts down the line, it will re-radiate along that line as well. And so you can get it through re-radiation. You can also get it where it is induced into another line that feeds your house. So now it's coming straight into your house. So those are the basic 4 ways that can happen. Anytime you got 2 electrical lines running parallel, one can induce into the other. It's just like a transformer. All right. As I mentioned, a lot of times it's good to start on HF when you're tracking noises that are being conducted a long ways down power lines. Basically, you're going to be following it, and you're going to try to decide, if I go this way, is it getting stronger? Are the peaks getting stronger? And if the peaks are getting weaker, then I'm going the wrong way. I got to go that way on the power line. You just got to go back and forth until you figure out which way is the direction to follow. Then when you get close to when it gets really, really strong, you're probably getting close to the source, then you want to switch over to the VHF and UHF, because now you're probably going to be able to pick it up direct radiation to your antenna. And I already mentioned the standing waves to watch out for. Basically, as you're walking down a pole, you're going to think, oh yeah, it's getting stronger. Well, no, it's getting weaker. So you got to try to figure out those peaks, which peak is going to get, compare the peaks basically is what I'm suggesting. You're going to say, well, it is getting stronger on my S meter or whatever meter you got. So as you walk along, you'll have to kind of get a feel for that.
You don't want the standing waves to fool you then.
You don't want them to fool you, yeah.
You're getting further away.
Yeah. And
And typically, as you're walking, how many paces will those peaks be? Any idea?
Depends on what frequency you're listening to.
Okay, that's true.
Yeah. And basically, this one shows the power line noise versus frequency. As you get higher and higher in frequency, it's going to basically get weaker and weaker overall, but stronger at those frequencies. So if I'm clear down where it's really strong at 1 megahertz, it's probably really weak at say 1,000 megahertz. So this all has to do with the distance as well. If you're getting closer, it'll get stronger, of course. But if you're just in one spot and you're just tuning across the band, this is kind of what you'd see on your scope if you had a scope like that. This shows the noise relationship to the distance and also to the frequency. The lower the frequency that you're picking the noise up, further away you can pick that noise up. But if you've got to be really close to get it at, say, 2 meters or above, that's going to be, just a few hundred feet away, probably 400 or 500 feet. Another noise that's out there that can kind of trick you into some things, corona noise. You walk by or drive under any high voltage power line, you're going to hear corona noise. It's there all the time, basically. That stuff drops off with distance very rapidly, and so you're probably not going to have an antenna close enough to a 345 kV line to be picking that up. And if you do, I would suggest moving it and getting somebody to help you. It's probably dangerous to do. But corona noise can actually get strong enough that it goes longer than what is typical. And so there can, yeah.
Sorry to interrupt. In a small town like Murray,
Mhm.
would the voltage be high enough in the town distribution to do corona?
Usually not, but there can be instances where if you're on the distribution system, say on the feed to a transformer, where you can get some corona developing. And that is usually just due to a lot of the materials that are hanging around that particular area of the line or of the equipment.
What voltage roughly are the voltages distributed inside?
That's,
of
I
the
think,
town?
13 kV basically, somewhere
13.
around that, 13.8 kV, I think is what it's popping in my head. Pretty inaccurate thing though, to go off of. But anyway, it's somewhere around there. Your other lines that carry from substation to neighborhood is like 69 kV lines. And those are more in between what I would call neighborhood power and transmission power. They're still part of the distribution system. Once you get up in the 161 kV and 345 kV, that's considered transmission lines. That's coming from the power plant out to all the substations. So that also can cause power line noise. Over the years, we haven't found too many instances of those until the last few years. And we're still trying to figure out why we're getting a lot of problem on 345 kV lines lately. It just is suddenly jumping up as a problem. Personally, I think it's a maintenance issue, but everybody's cutting down costs, you know, and like any other company, they're going to cut costs here and cut costs there until it finally starts to bite them. I think everybody remembers the big outage back east where a tree basically caused the whole New England to go down, basically. And that was because they started cutting costs on trimming trees. Eventually that bit them because they had a tree get involved with a problem on a 345 line. Once that 345 line went down unexpectedly, it just cascaded through the whole system. And didn't turn out so well for them. They really got in a lot of trouble for that.
So what's the easiest way to tell what a 345 line is versus your
Good question.
neighborhood stuff?
Look at the number of bell insulators hanging there. And I can't tell you the exact number, but you can tell if there's a whole lot of them, that's probably 345. If it's about half that number, you're on a 161 line. And if it's probably only 6 to 8 of them, you're on a 69 kV line or less. Yeah.
Would it also be safe to assume that the taller, the further away from the ground the wires are, the higher the voltage?
Yes, but they also make some lines capable of being upgraded from 161 to 345 in the future, so that may not be a good thing to go off of. But the insulators is a dead giveaway. Because if they were to upgrade that, they'd have to come and change those insulators out usually and change out the line as well to handle it. So, but corona noise, I haven't found that to be a big problem for the most part, at least at OPPD. I don't think I can even think of a single case where we had to go out and find corona noise. If you're living near a substation, however, you would probably have a lot more corona noise than, say, somebody that's miles away from there. So that, you know, we don't have a lot of hams that decide to live by substations for some reason. When I looked for a house, I saw the substation, I said, no, we're not looking at that neighborhood, so.
How far away from the substation are you talking about? Just
A couple miles probably, you know. I would say that subs that can cause interference when you're living like right across the street from one or in the neighborhood right next to one maybe. I would say when I drive through certain substations, we usually find lots of corona. But that's when we drive through the substation. Once we get outside the substation, we probably, you know, don't even have to get on the road hardly. We don't hear it much anymore.
You mean like the street, when you say the road?
Yeah.
Get out the street, it's going.
Yeah, when we were looking for trouble on a 345 kV line down south for Rick Atwood, I think is his name, we went all the way up to the sub that's on South 36th Street there, and I think Cornhusker Highway. And yeah, it had a lot of corona noise inside the fence. Once we got outside the fence, we couldn't really find corona noise. But we weren't even looking for corona noise on that case. We were looking for if it was getting stronger coming up to that sub or getting weaker going away. And we eventually figured out it was getting weaker going towards the sub. So it wasn't coming from the sub at least. But it was kind of interesting driving through that sub and hearing what Corona sounds like. Okay, common sources of power line noises. You got hardware on all the poles that can get loose, and that can cause arcing in between the hardware. There are what they call slack span insulators. If you got strings of insulators that are on a slack span, and I'll show you a picture of what that looks like here in a minute. Those can be very good sources. Lightning arresters can leak real terrible after a while. They just start to break down and make noise. High current connections that don't have a low resistance anymore, as they start to build up resistance from corrosion or whatever, those can become pretty noisy as well. High voltage lighting that has arc type connections, those can also cause basically power line noise. It's all arcing of one kind or another. The insulators, the bell insulators are notoriously noisy insulator, and they crack easily over time. They also get dirty over time. That can cause interference. Those always seem to be one of the things we key on is the bell insulators. And I mentioned the squirrel guard. That one noise where it sounds like Jacob's ladder. Basically,
Gonna have a picture of the squirrel guard? I don't know what you're talking about.
I don't really have a picture of the squirrel guard, but basically it just looks like this, with metal sticking out in all directions in a circle. And I'll stick that around the insulator, and then that'll keep the squirrel from getting down underneath into the high voltage connection. And once in a while, the squirrel will be jumping on that, and maybe he'll fall from some distance and hit it. Now he's bent it. Now it's a different shape. Because it's a different shape, you can have an arc develop there, whereas it wouldn't if we were all equal. And so the one that we found in my neighborhood basically just had that problem. It just got bent, they were bent in really close, and it made a perfect Jacob's ladder when it, when it felt like it. And it would come and go, and then finally it would just stay on solid for a while. There's one of those slack spans I was telling you about, and I think you can make out the bell insulators on both ends. There's two of them here and two over here. Those are usually pretty notorious. It's the connection underneath them and in between them that can get really noisy. And so one of the fixes, we've got a couple of things we do. It can put straight up DW40 on there if it's just corrosion that's causing it. There's also what they call an RIP. It basically reduces interference by tightening up that connection. You put the clip in there and it just kind of firms everything up, and so it's not loose anymore. So a lot of times they'll put both some lubricant and put one of those clips in there. I keep trying to get them to buy more clips. When they run out and then they don't think about it, they don't use them anymore. So, so then I tell them, well, if you can't do the clip, replace that with a better insulator. And I think I got a picture of those coming up. Yeah, the fiberglass rubber insulators are basically noise-free, I call them, because very little, few times do we ever have RF noises coming from those. Those are pretty sturdy little devices, and they like I said, we don't hardly ever find problems with those.
What would be the voltage on that? Quick guess?
I would guess that's probably 13 kV.
Because it's a one,
Yeah, it's
the
just,
bell is a seven
yeah,
on that.
that just looks like a neighborhood run. Lightning arresters, I mentioned those can fail. This particular one is an interesting example because they've installed the cable at the bottom wrong. He's got a sharp edge on the connection right at the bottom of it, which is right here. It should be bent this way, not this way. If you bend it this way, it would act like a better lightning resistor. In that position, it's probably not a real good lightning resistor, but it's just going to do something that makes noise.
It's too close to the support below, is that?
No, you want to keep your angles of your wires in a very natural curve. That way,
No sharp bends.
No sharp
yeah,
bend.
no sharp bends. You're creating, basically with lightning, any impedance and all, it'll find someplace else to go. So it'll jump over to something else on there, like the ground wire, hopefully the ground wire, or the actual electrical wire going into your house, That's not good either, so.
The other piece there is a fuse, is that right?
That's a fuse, yeah. And those guys will come open those and close those as they need to open up and close a line so they can
Point out
off
the
line.
fuse.
Those are supposed to open if there's a lightning strike or...
Well, the lightning arrestor is there for that. The fuse cutout is basically there for the human to come open and close.
Right.
Yeah.
I thought those dropped if there was an overload in the circuit.
It can, that's not the actual intent for them, but yeah, it's kind of a backup to the fuse, or a backup to the lightning arrestor zone.
So you have a hinge at the bottom of that rod,
Mhm.
right, and then just pull
Yeah.
it pulls away.
Yeah, they can go through with a big stick and just pull it open.
Yeah,
Yeah,
there's a loop
I'll
on
pull
it.
them open if they're working on a lot.
But see, if you notice on that, there's all sorts of connections that can,
Oh, yeah.
that can be noise sources.
Sure.
All sorts of hardware on those things. All of that, once it gets loose and starts to corrode, it becomes a noise source for us. And then we have to have them go back and replace it with something and tighten everything up. Transformers, generally, once they're bad on the inside, they'll eventually blow up and go away. That's all I can say. So, you know, yeah, and a lot of times we'll have, if we have a noise problem to a ham and it's the transformer, it'll blow up before we find it. We'll go out and look a few times and we can't see it on an ultrasound if it's internal to that box. We cannot see the noise on an ultrasound. So our tech will go out and say, yeah, it's from this bulb, but I'm not getting any noise. I'm standing there with his ultrasound and he's like, there's no RF noise from that bulb. So he thinks it's a clean bulb. A week later, the transformer blows up, problem solved.
You ever use an infrared thermometer to check them?
I've tried using that, but I don't find it as good as ultrasound.
Yeah, okay.
Yeah, it's really hard to tell what's going on the infrared. It's a neat device, and they do use that to fix corona problems in
Oh, yeah.
substations.
I can see that.
Yeah.
Because the connections are pretty hot,
Mhm.
if there are.
Yep.
Yeah.
And the thing on the transformers that I think I already mentioned, the squirrel guards on the top, when those get messed up, that'll be a good source. And you got to be far away from them with the ultrasound and to see the top of it. So then that's one thing I've warned the guys about is, you know, make sure if you can't see it from the bottom, walk out across the street and
What
see
kind
it.
of frequencies are developed with the ultrasound? 40 kilohertz or?
It's down basically just above natural hearing. Yeah.
Okay, yeah, 25.
20 to 40 to 60 kilohertz.
Okay.
I haven't used one of those in quite a while, but yeah, it's somewhere in that range.
I can see the arcing would create that
Mhm.
sound.
Yeah. But when it's inside the transformer,
Yeah, you
can't hear it outside. So, all right. So, kind of go over things again. First step, if you got power line noise, make sure there's no inside sources. Try to figure out if it's in the house or outside the house. Next thing you can do is you can take several, you can start DFing and take and write down where, every time you find a noise source, write down where it is. If it's got a pole number, write it down. If it's one pole past where the transformer is, write down the transformer number if you can read it. Say it's one pole north of the transformer. Do that kind of note taking, and then you can kind of give us a list to start with. Now, I'm not telling you to go out and do our job for us. I know it sounds like that, but what this does is it speeds it up, because here's what we got. We've got technicians who are radio engineers, radio techs, and their job is to take care of our radio systems. This is just an extra thing they have to do. And so if there's really something serious going on with the radio system, you're going to be second fiddle to that. And many times we don't even have enough guys on staff at times to get some of our normal day-to-day work done, and then in come a couple of our I-calls like, all right, who wants to work overtime? You know, start dragging them out for that. But go out and DF and write down all the noise sources you can locate. Like I just said, what we're trying to do is just trying to minimize both the amount of time it takes for us to get your problem resolved and the amount of time it takes for our guys to get out there and do this work. If we've already got an idea it's somewhere in this vicinity, in this neighborhood, then we can go out and take the ultrasound out and say, that's a clean pole, that's a dirty pole. And then we might even come over to your house and hook up to your antenna with, yeah, I guess I forgot about this. I'll let everybody come up and see this afterwards. This is our receiver that we can take portable. And then we hook up this, we can either hook up a loop to this on HF, and then we'll take a reading, and we'll get a scope reading, and put it in memory. And then we'll go out and walk your neighborhood and look for a noise that looks just like that reading. Once we find one that matches, we say, that's your noise source. We found 4 other ones, but that one matches the best. We'll probably clean up maybe 2 out of those 4, because one of them was close. But if we find one that's an exact match, we'll make sure that one gets done for sure. And that just makes it a lot faster getting things done, as far as getting the crews out to get it fixed. Now, is everybody here OPPD, or do we have anybody here from Iowa? Anybody from Iowa? You're from Iowa?
But down south in Murray, I think, is NPPD.
Oh, okay. So, yeah, there's some towns that are covered by MPPD here and there too, yeah. Iowa's a whole nother ballgame. I know that some hams over there, I've gone over to help a lady over in Council Bluffs one time, and there are some issues with the guys over there don't have the right equipment. They don't have really the know-how to go out and do tracking. So many times they're left hanging in the wind. And so if the ham doesn't go out and say it's in that hole, they may never get their problem resolved. They have to pretty much go out and find it for themselves over there. Once they get somebody out to fix it, though, then they get it fixed. So, you know, eventually it does happen. Here's what I suggest. If you have any problems with OPPD, especially our customer service people, they don't even understand radio, period, much less radio frequency interference. I'll give you a phone number here. You can call that. That goes directly to my department, and then we'll get a ticket made directly off of that then. But we like them to go through the normal source, because then we get credit for taking calls from the public. Otherwise, they don't give us a lot of credit for stuff like that, I guess. But if you have trouble with the utility anywhere else, and I read about this all the time, the first step is to call the ARRL. They'll send them a letter. And believe it or not, we've gotten a letter from the ARRL ourselves even before, on a case that took too long to get resolved. And it does happen, unfortunately. And once that happens, the ARRL lets the FCC know that they're in contact with us, and then we usually see a letter from the FCC shortly thereafter. But if you go through the ARRL first, I think, who was it? Hollingsworth set this up where there's an agreement between the ARRL and the FCC that the ARRL will take all first cracks at these problems and try to get them resolved between the ham and the utility. So my advice is always to try the ARRL first if you are having problems. And then if you still aren't getting anywhere, you can call the FCC directly yourself. We have, I'm trying to remember, we did get one letter from the FCC even back in 2001, I think it was. And that was because my boss sent out a letter saying we're not going to solve this problem for you, we're done, we spent too much money. Should have just asked me, I would have said, don't send that letter, you're going to get us in trouble. And she got us in trouble, so. Anyway, she's retired now, thank goodness. But it happens, you know. And you know, we get a new manager on the T&D side, and he comes in and says, we're just wasting too much time helping you on this stuff. What are we doing this for? And then I got to explain it to him all over again. Part 15, this and that, you know. And it's a regular cycle as they promote people. We get a new guy in, I start all over with a new guy. It seems like every time. So it's an internal battle that, you know, the communications has to fight, communications department does fight. And for the most part, we know the rules. We do try to follow them. If you're hitting a brick road with the customer service, let us know, let me know. And I think Jack probably gave me an email here a couple months ago when he was having trouble at a place where he was helping an elderly lady. And then we ended up fixing a whole bunch of noises, and then he moved. Yeah. And he said it was still there when he moved. So there's still noises out there on Pryor Street or someplace, Pryor Avenue. If you move by there, we'll come out and fix it eventually, but not until somebody complains. And he left, so there's no more complaining. And we're not going to go clean up every neighborhood, because my gosh, you know what your electric bills would be if we kept them all really clean? You couldn't afford electricity at that point. You know, it would just be too expensive. So we really need to just focus on getting those sources that are causing you guys the problem and getting those cleaned up. And the best way to do it is just keep hounding us. And we also need you guys to cooperate with us and meet with our guys when they're on duty. So you may have to take time off from work and that sort of thing. Here's the phone numbers. I actually had some old ones on here. I just changed them today, so I don't have them memorized. 536-4131, that's the customer service folks. in Omaha. If you're outside of Omaha, it's an 877 number, but the same number then. I got Mid-America Energy down there if anybody's from Council Bluffs or Iowa someplace. I've already mentioned, keep notes on all your calls to the utility that you're talking to. Any conversations, the tech comes over and visits you, note down what he told you. I have listed here make noise recordings. That's maybe good for helping you analyze the noise. The tech himself, he'll be hearing it himself, so we probably don't need you to email those to us, although we've had people call up with their phone and leave us voicemails and just put 20 minutes worth of noise in there. So. Yeah. Okay.
You didn't like that one? Well, that's not so good.
No. But anyway, if you keep a recording of the noise, you can sometimes tell there's more than one noise there at times. And we'll come out and we'll find that first one that we see on the scope, and you'll still have noise. What we just did was we peeled the onion, and we found a new noise underneath that first layer that we took away. It got weaker, so that means we found a new noise. And we're in that stage right now in my own neighborhood at this point. We've got Ham north of me, that when the noise went away, he still had a weaker noise. And I said, well, too bad, because I don't have any noise down here.
But you're talking about Phil.
Phil, yes, Phil Ball. And so we've got to go out and do one more track on him. I think we've got a transformer line that's given us some noise, and there's two other noises right by Corby's place. I'm surprised he hasn't called. It's right across the street from his backyard. Yeah, exactly. So, like I said, be prepared to take a little time off from work and meet with the investigators. So, any other questions? You guys have been good at asking questions as we went along. Anybody got? Yeah.
If we call customer service, could we ask them for your department? What would be the name of your department?
Communications department.
Okay.
Yeah, and then we'll put you through our. We're down to. We used to have 4 clerks. We're down to 1 clerk now. Just like everybody else, they cut until we can't cut anymore. And Kathy will probably be the one you'll talk to.
Does she know what I'd be talking about if I ask her?
She knows all about RFI.
Okay.
She'll know how to put a ticket in and get the radio crew on it. And so she'll ask for your address. She may ask you a few other questions, but she's not real technical herself, so she won't start delving into things that the technician will when he gets a hold of you. But we'll need your name, your phone number, your address, and she may even say what time of day are you getting the noise. Because then if it's only happening to you at night, we'll have to coordinate some overtime to come out and figure that out.
Are any of the poles have badges on to tell what they are?
Not all of them do.
Marked, I mean, on AM.
Yes,
marked.
not all of them are marked. Some of them you'll have to say, well, there's a transformer 2 poles down, so this is north. The pole that's two poles north of the transformer, and then you can go down and get the number off the transformer pole. Usually that pole is marked. If they got a lot of hardware on them, the more hardware they have, more likely they'll have some sort of marking on them.
Now I was curious about one of, those 3 transformers on the pole that you showed.
Mhm.
How much does one of those weigh?
I really don't know. I don't
500?
order those, I don't install them. I know they weigh a lot, but you have to use a crane sometimes to get them up there,
They
so.
don't put them on the bag with that.
Yeah. We got big cranes for that stuff, I know, so.
Probably pretty expensive, all the oil and stuff.
Yeah.
You mentioned cracked insulators. Have they had problems with hailstones damaging them?
Usually, I don't think hailstorms are the biggest problem. I think it's just over time, it gets hot, and then they get filthy dirty sitting up there all the time. And sometimes you have wind that will swing it around, and just that kind of pressure on it, with the hardware connected to it, causes it to crack. Yeah.
I got a story. Council Bluffs, I got an AM station over there on 1420. One day I'm driving down the road as I nail my poles on 1420, I hear a buzz. And the buzz was pulsating. And as I got to the transmitter side, it even got louder. To make a long story short, I took a field strength meter and I went into the transmitter building and found where the source was the loudest. And it happened to be in the fuse box, in the breaker box. So that told me there was something electrical possibly on the outside. So I got a hold of Mid-American Energy. The guys came out. And what it ended up being, after tracing it down for about a week, copper thieves came along and stole the the ground system off of the pole.
Yeah.
I mean, they went right down the line, and everywhere where that had been cut off, that's where it was the noisiest.
Yep. Yeah, without a ground, you're gonna find that the
Yeah.
arcing has nowhere to go but out into the air.
And those guys, in some cases, are taking a real big chance when they're making that cut.
Yeah.
Oh, yeah.
Yeah, I've seen pictures of guys they found in substations the next morning. One guy had his arm completely burned off. Wow. At the elbow, basically. And he was cutting something and boom, he was gone.
Anybody's doing it to do that.
Yeah,
Yeah,
not a good thing in a substation.
It's
called natural selection.
This guy went into a substation and he found the very highest voltage he could find and took his arm right off.
And the most copper attached to it.
Has the most copper attached to it. They were looking for copper. Yes, sir.
Street lights are in your purview?
Yes, we have had some street lights cause noise, and that's usually the easiest one to fix, because we can get the street light crew out there right away and change up whatever the bulb or whatever electronics is.
One in the front of our house that just cycles all the time. It's on and off, on and off.
Report that, because, yeah, that eventually could be an RF problem for you. Yeah. It may not be at the moment, but eventually it could build up into a problem.
Yeah.
I didn't hear that, okay.
What?
Also, one thing I do not recommend, and John was here to tell me, one of his methods was, if you got an intermittent noise, he goes to the pole, he thinks this, and hit it with a sledgehammer. Okay, if it's loose, and if it's really loose, you're about to knock it off, and you're right underneath a hot light power line coming down on you. So I really don't recommend that.
That's John.
Yeah, some of the guy wires they have on there can actually have noise on them too. I actually found noise without a receiver. My guy was walking through with his ultrasound and his earphones on. He didn't hear it at all. I went by and that's a noise. I can hear it right here. You know, I just about rubbed my ear against it. I could hear it. So, and then I just took and pushed on the yellow insulator and it's gone. And as I'm doing that, he's going around. Couldn't hardly tell him, but yeah, that was an easy one to find. Any other questions? All right.